141,000. That's the number of people that have died during the opioid crisis. And to put that in perspective, that's about 12 times the number of students that attend UCF right now. And I'm sure this is not the first time you've heard of the opioid crisis. It's been ongoing since 1999. And the CDC still estimates that 136 people every day will succumb to their addiction to opioids. And pain management is very real for people. And everybody senses pain just a little bit differently. But alternatives are lacking. And fewer than 3% of drug compounds in this category will even make it through phase 1 clinical trials of 3. But if we take a patient-centered approach, there may be something we can do. Now, my dissertation stands at the crossroads of biology and nanoscience or technology, which gives an interesting perspective from which to tackle this problem, because we're not the usual approach, but there is something we can do if we play to our strengths in that field. So the questions to motivate this research are not what these safe and available alternative compounds are, but how can we more effectively screen these compounds and provide an individual the alternatives that they need without putting them at risk. So I developed biosensors that use really small electrodes called microelectrodes, and they're able to get signals from electrically active cells like neurons. So in the middle there, we take patient tissue and we can put it on the chip, you can see right in the middle, and these neurons will grow together and form a model of the spinal tissue that we're interested in. So if we go closer, we can use that green framework to make this process more repeatable. And as these neurons grow through the electrodes and as they interact with their environment, the signals they give us will change, and we can measure that. So the final device you can see up top there that's fabricated, we need to characterize that for its electrical components and how that impacts the sensitivity of our device and if we can get readings from that. We also have to look at the materials that it's made from, because that impacts how it works, and also if the cells will acclimate to their new environment. We also need to look at the biology on the chip, of course, and we can do that through staining, which lets us know if we've successfully created that model, and also if the populations of cells that we're looking for are present there. But the seemingly life-saving part of this will come from those random-looking lines at the bottom there, and that's what these neurons actually look like when they're communicating on one of these devices. So when we change these compounds and we try the older ones and we try these new safe alternatives, we can find out what will actually work for an individual. This research is part of an initiative with diverse researchers that are all tackling this crisis through different lenses. And of course, there's more to be done. But I am confident that our small technology can have a really big impact on this crisis through personalized medicine. Thank you very much.